Thank you. I first would like to thank to the organizers for having this wonderful workshop and giving me this opportunity to talk about my recent work with Byung-gi, Chiang, and Hyun. Chiang, actually, the previous speaker. And about also my ongoing work with Min-sung. He's another postdoc in TIAS. So let me begin. Oh, yeah. So supersymmetry is one of the most intriguing structures in theoretical physics. And you can use so-called localization technique to compute many things. And you can actually check many non-perturbative dynamics of some strongly coupled systems. And it is very interesting to find some non-trivial relations to non-supersymmetric objects, since the machineries that we developed by using this localization technique. So you can use this to study this non-supersymmetric object also. For example, you can study 3 manifolds, or you can also study some 2D vertex operator algebra as well. And one of these famous examples would be the 4D n equals 2 superconformal field theory and 2D vertex operator algebra correspondence. So let me explain about this a little bit. So 4D, this is so-called 4D n equal 2 and 2D BOA correspondence, and the statement is very simple. So once you have, if you have some 4D n equal 2 SCFT, then you can consider some sector, which is called some sure limit sector, which satisfies some special quantum number relation. And if you collect that operators, and you can check the OPE structure is exactly the same to some to the vertex operator algebra OPE structure. So if you count that sure operator, which is called the sure index from 4D n equal to SCFT data, you can actually check that is the same to vacuum character of this 2D vertex operator algebra. One example would be is 4D n equal to A1, A2R Argyres-Douglas theory. This is known to correspond to the vertex operator algebra of M2, 2R plus 3 2D Virasoro minimal models. And this sure and Cordova and Shao explicitly show that this sure index matches to the vacuum character of that Virasoro minimal model character, vacuum character. Such vertex operator algebra can also appear in the 3D context. So if you consider 3D n equals to 4 superconformal field theory, the R symmetry group is SO4 R symmetry. And you can decompose it into 2 pieces of SU2 symmetries. Let me denote it as SU2A and B. And you can use it to do some topological twist by identifying this symmetry to the Lorentz group of 3D. And if you use this, then that is called A twist. And if you use this is called the B twist. So that you will obtain some cohomological topological field theory that is denoted as TA and TB. And in general, if you consider some general 3D n equal 4 CFT, then there still exists some local operators came from Coulomb branch for TA and comes from Higgs branch for TB theory. So in general, the topological field theory TA and TB have such local operator, and the resulting vertex operator algebra that can be supported on the holomorphic boundary is non-rational, so that it is a little bit tricky to deal with. However, if you consider some special 3D n equals 4 SCFT without Coulomb and without Higgs branch, then there will be no local operators after this twist. And you can check that the corresponding vertex operator algebra becomes rational, and it is rather well known. And so this special 3D n equals 4 SCFT is called 3D n equals 4 rank 0 SCFT, where rank counts the number of dimension of Coulomb and Higgs branch. And it was first found by Gang and Yamazaki in 2018. And after that, including me, my collaborator found some more examples for rank 0 SCFT.
In the 40 equals 2 story,
yeah.
Usually the central charge of that you get in the effective 2D vertex set by the anomaly coefficient in 4 dimensions. Usually it's negative. You have some non-unitary.
Yes.
What sets the analogous story here?
Yeah, all these vertex operator algebra from this construction is non-unitary actually. Yes, exactly.
And what's determining the central charge?
What's the, sorry? What is the central charge? We don't know how to do that actually still. Yeah. Thank you. Okay, so let me give you an example. 2 years ago, that was known from 2 years ago. And if you consider some 3D n equal 2 SCFT given by this meta contents, that is R of U1 gauge groups whose Chern-Simons level, mixed Chern-Simons level matrix is given by this, which is nothing but the Cartan matrix of Tadpole graph. And R of chiral multiplets, each of them are charged each of the U1 positively. So because we are considering 3D, we have U1 topological symmetry for each U1 gauge group, so that in general we have R of U1 topological symmetries. But by turning on this R minus 1 of half BPS monopole operator, which are charged under the U1 topological symmetries, so that you can break R minus 1 of them, so that the remaining one U1 topological symmetry will become the U1 axial symmetry that gives you n equals to 4 enhancement. So this theory looks like n equal 2, but actually after turning on this monopole operator superpotential, you can check that this actually enhances to n equals to 4. And because you have this n equals to 4 supersymmetry, you can perform topological twist, A and B twist. So upon A twist in the Berg 3D, you can check that the corresponding vertex operator algebra on the holomorphic boundary is given by that of M2, 2R plus 3. So note that when R equals to 1, this reproduces Gang Yamazaki's T minimum theory. By the way, the name T minimum is because the 3-sphere free energy of this theory actually has the minimum value of, which is kind of measure of degrees of freedom. And this has the minimum value for this theory, which is even smaller than a single chiral multiplet, free chiral multiplet. Also note that the B-twisted theory, B-twisted vertex operator algebra is known to be affine OSP 1/2 at level R. And it is soon discovered just after this work. And it is, so A and B twist is also known to be related by level length duality. And this A and B twist also related by the mirror symmetry of the 3D n equal 4. So there are many interesting structures in this story. So one may ask, it is wondered that how this 4D and 3D can be related to, that gives the same vertex operator algebra, 2D vertex operator algebra. So the answer is given by Mykola Dedushenko in 2 years ago, and that is a holomorphic topological twist. So if you consider 4D n equal to SCFT on R2 times C, where this R2 will be the topological direction, and this C will be holomorphic direction. And after you do topological twist by U1R symmetry on this topological direction, and pattern of SU2R symmetry for this direction, and by doing this omega deformation, you can make the topological plane into this cigar, and because this omega deformation makes the Poisson algebra on this plane to localize to this tip of cigar and make some 2D vertex operator algebra on this holomorphic direction upon some circle compactification. And this U1R symmetry twisting acts to the local operator having conformal dimension delta to with this phase. So if you consider some Argyres-Douglas theory without Higgs branch, Argyres-Douglas theory by definition having Coulomb branch operator, that operators having a fractional number of fractional number of conformal dimension. So this action is non-trivial. And because this action is non-trivial, all the Coulomb branch operator of this Argyres-Douglas theory is lifted, and there is no remaining Coulomb branch and Higgs branch in this 3D theory, which is nothing but the rank 0 SCFT. So that you can do some topological A and B twist to get some rational vertex operator algebra on this holomorphic plane. And this picture is severely checked recently for A1 and G type of Argyres-Douglas theory. Also, the papers by Dongmin and Nicola and Arash, they also considered flavors, the cases having Higgs branch also. And we also considered such cases also. So there are many checks last year. So among them, let me introduce the method using trace, so-called trace formula. So this method uses the data of Coulomb branch of the 4D n equal to SCFT. So consider some point U on the Coulomb branch of 4D n equal to theory, and the dynamics, the effective theory will be electromagnetic theory, electrodynamics, and it becomes the BPS particles are the stable states of that effective theory. And the data of that effective theory is described by these two set of data, where gamma is the electric magnetic charge, ionic charge on some ionic charge lattice, and the central charges for each gamma, which is nothing but a function valued in complex number. So the claim of this paper by Davide Gaiotto and Sungjoon Kim is that if you compute the trace of these some specially organized operators with a special function phi b, compute some 3D ellipsoid partition function at A-twisted, topologically A-twisted theory. Here, the trace is over some auxiliary Hilbert space along the charge lattice, and these X gammas satisfy this Weil algebra originates from Dirac pairing of gamma and gamma prime. So this special function phi b is nothing but this famous Faddeev quantum dialogism, which is defined by this integral expression. And this function actually satisfies very nice rule, nice properties. So first one is fusion. As you can see, if you fuse x and minus x, it gives you some Gaussian-like vector here. And more importantly, this satisfies the pentagon identity that for gamma and gamma prime satisfies unit Dirac pairing. So if you take gamma and gamma prime, then this becomes three of them, gamma prime first, and gamma last, and in between there appear gamma and gamma prime plus. And this pentagon identity actually encapsulates the word crossing identity, such that this trace is nothing but the word crossing, one of the word crossing invariants by construction. So by the way, this product is ordered product along the clockwise order of phases of this central charge. So let me give you an example. So yes, complete circle. So let me give an example. So if you consider A1, A2 Argyres-Douglas theory, then we know there are two distinct chambers separated by this some dashed line, which is wall. So in the first chamber inside this wall, we know there are two stable BPS particles having charge gamma 1 and gamma 2, where this gamma 1 and gamma 2 satisfies Dirac pairing with unit value. And outside this chamber, the second chamber, we know there are three BPS stable particles, where the ordering of the central charge is changed. They opposite, they crossed. So at the wall, at this wall, the central charge of gamma Z1 and Z2, they overlap. And if you cross further, then they exchange it, making another bound state with charge this, gamma 1 plus gamma 2. So this is the situation on the Coulomb branch. Okay. So at this chamber, the trace formula will lead this. So clockwisely, you first write down gamma 1, gamma 2, minus gamma 1, minus gamma 2. Likewise, you can do for this. Gamma 2, gamma 1 plus 2, gamma 1, gamma minus 2, etc., etc. So this actually, you can check immediately that this is the same by the pentagon identity that I told you in the previous slide. And you can actually using the nice properties, nice identities to simplify these operator valued functions into this trace. And if you can see that you can treat this algebra as x1 as momentum and x2 as position operator, because this is some C number. So by considering that, you can plug in some completeness relations to make it as some integral expression like this. And this is nothing but the integral expression of the ellipsoid partition function of Gang-Yamazaki's T-minimal theory. This is the first example. And by using so-called the Bessel-Root technique, you can extract the modular data associated to this rank 0 theory's A-twisted sector, so that you can check that for A-twisted sector, you can check that the VOA, corresponding VOA, comes from M2,5 minimal Virasoro minimal model. And from at the B-twisted sector, you can check that this is affine OSP 1/2 at level 1 with vertex operator algebra. You can also, interestingly, consider taking some powers n for total of this monodromy operator. And the result looks like this. So you can do the same game to simplify and making it some integral expression to read some 3D theory. And we could check all this 3D theory, admit some topological sector, and could compute the modular data S and T, partial modular data S and T, to identify this set of modular data. And note that if you take n equals to 5, before you taking trace, you can actually check that this operator just becomes identity operator. So even if you consider n equals to 6 power, it is just the same as n equals to 1, because n equals to 5 is nothing but the identity operator. So there are only finite number of set of some modular data, and this makes some family of vertex operator algebra related by Galois shuffle or Galois conjugation. So in summary, from A1, A2 Argyres-Douglas theory, you can find a family of vertex operator algebra.
Those n equals to 3, 4 interpretation, original theory, or is it just sort of solution?
That's a good question. Actually, on the column branch, we have some so-called R-flow argument, and using that, we can interpret that as some multiple looping of some Janus loop. Maybe I can explain you later. Yeah. So.
Also,
yeah.
This pentagon identity of what person has anything to play in any of this? Because you walk through left-hand side. What is the point of pentagon identity?
And this side.
Yeah.
Yeah. This is just same as this. Yeah.
This is used right-hand side for something in this story.
We get the same theory. We get the same theory. Indeed. Yeah. Sorry. What is?
Is a white person enters in any sensible way here in the story? Because if you are dealing with invariant, it's a completely oblivious to what person said.
Mm-hmm.
Right? You could not, you could have go down the left-hand side and be happy, or you need this right-hand side as well?
We just need a point with a finite chamber. Yes, that is enough for doing this game. Yes, that's a good question. Yes. Okay, so in my recent work, we could do the same game for many examples where G labels ADE with length, some Lie algebra ADE with length equal or smaller than 8. And C also did those papers by other guys, which have some similar discussions also. Okay, now let me tell you about my ongoing work with Sungjoon Kim. So my question is, it's very simple question. Can we do this for general GG prime Argyres-Douglas theory? Because we know there is GG prime Argyres-Douglas theory. And the answer is, of course, yes. And we could do this by considering some BPS quiver, the so-called BPS quiver of GG prime. And it is known that the BPS quiver of this Argyres-Douglas theory is given by this so-called square product of Dynkin diagram G and G prime. For this specific case, the G is A3 and G prime is A4. And this is A3, the BPS quiver of A3, A4 Argyres-Douglas theory. And we need the data of how many BPS particles we have and their central charge ordering along this complex number phases. So we could actually compute them by using the quiver mutations, and we could check that the number of BPS particles in some finite chamber is given by positive root of G times simple root of G prime. So there is such a special finite chamber we could find. And using this data, we just plug in to the trace formula to computing some ellipsoid partition function. And actually, for some technical reason, it is very crucial to simplify the trace formula sufficiently for using the Beselut method. And this was solved very recently by developing very efficient machinery which is nothing but mathematical code. And actually, this is developed. This is written by Min Sung, and if you're interested, you can talk to him. So from this data, from this trace formula, anyway, we could find various rank 0 theories from A and A type with N and M are co-prime. This condition is nothing but the same as the theory, the Argyres-Douglas theory doesn't have Higgs branch. So that the resulting theory would be rank 0 3D theory. And the corresponding vertex operator algebra, we could check that many of them becomes this expected result, Wn, n, comma, n plus m, they are sort of minimal models. And in general, whenever G prime Argyres-Douglas theory do not have flavor symmetry, do not have Higgs branch, the trace formula seems to give 3D rank 0 theories. And even if there is a flavor symmetry, they seem to give some unitary topological field theory. And it's very interesting that checking that many of them are just become just pure Chern-Simons theory, Abelian Chern-Simons theory. So, and also we could also check that the periodicity, there is some periodicity of this monodromy operator. For example, when for AA type, the periodicity is given by this number, which is cooked up from dual Cox-Otto numbers of G and G prime. All right, so let me summarize. So by applying this trace formula, we could find various vertex operator algebra data from 3D topological field theory that comes from Argyres-Douglas theory. And we could check this works as well for arbitrary G and G prime Argyres-Douglas theory. And here's my question that I want to address. And yeah, this is all. Thank you.
So any questions?
So in the example you worked out with n power, did you mean that for n bigger one?
N bigger one,
Yeah,
yes.
You have a different theory whose particular function?
I'm sorry, I didn't get
So,
there. Yeah.
Could you go back to the example?
Yeah. Yeah.
N from 1 to 5.
This one, yeah.
So for n bigger than 1,
Mhm.
Are you considering different theories? Different n equals 2 theories?
Yes, yeah, they come from different n equal 2, look like n equal 2 theories. Yes.
Okay.
Yeah. I mean, yeah, this ellipsoid partition function it changes when you change the n.
And how are these theories related again? Maybe you mentioned.
They are related to by Galois Shopper, which is nothing but relabeling of this modular data. Yeah. Yeah, we could check that. Yes.
Because, I mean, at least you go through the central charge plane once.
Yes.
1, 2, minus 1, minus 2.
Yes.
So if there is a new theory that will be n equal 2,
Mm-hmm.
so your 1, 2, and minus 1, minus 2 has to be on one side of central charge plane.
I'm not sure what you're meaning.
I mean, gamma and minus gamma in central as a state.
Yes.
State definite relation between the two. It's not 1 and 1 prime. Their charge is opposite. Their central charge is complex conjugate of each other.
Yes.
So it's more like going through central charge plane twice or 3 times.
Yes,
instead of
exactly.
going around once.
Yes, yes. We're going around multiple times, which means this n. Yes.
So you're saying that there is a theory where going around once is exactly the same as going around twice in this plane. Is there n equal 2 field theory such that if you go around once, you collect 8 such things, it is same as going around
Ah,
twice?
No, we couldn't find such cases.
That's right. So it doesn't mean that you have theory for n equal 2. It's just mathematical construct that you start from 1
Yeah.
to 2, and that happens to give you another protection.
Yes, exactly. Yes.
Sort of solution that will be technical.
Yes, exactly. Yeah, you're indeed. Yes.
They are not equal to theories.
N equal 2 in 4D n equal 2. So yeah, that is not come from 4D n equal 2 theory. Yeah, I thought that's 3D n equal 2. Sorry. Yes. Yeah. Yes. Yes.
Is there any kind of idea about generalizing this kind of formula?
Oh, exactly. Yes, exactly. So there is some other, the structure is the same, but instead, if you use, for example, some Q exponentials or something else, and you will obtain some other word crossing invariant object. Yeah, for example, yes. You can also compute Schur index. Yes.
What about, for example, something like a 4D? It's like a CFI.
That's a good question, but we don't have such kind of still. Yeah. As far as I know.
More questions? All right, then let's thank the speaker again.
Thank you.